In this video, we will add another file writer block to an existing mission. This is the same mission we discussed in the previous videos. The raw IQ file writer block is collecting raw IQ information directly after the A to D converter of the Spectran V6 device. It streams this unfiltered IQ data to the hard drive. Every individual sample is preserved, and the Float32 IQ format lets you post-process the recording either in the RTSA Suite Pro GUI or externally, for example in Python, by reading the raw IQ data. In the second video, we looked at the file writer that records after the IQ Spectrum block. After the IQ Power Spectrum, some filtering has already been applied. So there is a clear difference between the raw IQ data at the input and the IQ-derived values at the output. In that path, the file format is RTSA, which is an internal Aaronia recording format. You cannot simply open those RTSA files in Python for post-processing. They are meant to be replayed inside RTSA Suite Pro. The advantage of this path is that the data has already been filtered by the IQ Power Spectrum settings. To recap, the IQ Power Spectrum configuration allows you to define FFT windows and FFT sizes for the collected data, which shape what is recorded at that stage. Now, we will add a third file writer, this time after the waterfall block. Add a new file writer block and connect it to the output of the waterfall block. This gives us a new block, which we will call File Writer 3. You will find its properties in the lower right panel. We will quickly walk through the configuration. In the block properties, change the title to File Writer Waterfall. This makes it clear that this writer collects data after the waterfall. As with the previous writers, you can configure the file name either in the block list or in the Properties panel. Here, we will do it in the Properties. Set the file name to file_streaming_waterfall. The default file type remains RTSA, so we keep that. Now this file writer will store its recordings in the temp/audio directory. We would like this recording to start automatically whenever we click the main Start button. So we enable Auto Start for the File Writer Waterfall. For this demonstration, we will not add an index or date to the file name. Once again, you can define the maximum size of each file. The configuration is very flexible. You can limit by file size, by duration, or by folder size. If you want the recording to be time-limited instead of purely size-limited, you can set a maximum duration. To protect your hard drive, you can also enable a max folder size and specify a threshold at which recording should stop. Let's move the Properties window slightly and look at how this fits into the overall signal flow. We already discussed the filtering that happens in the IQ Power Spectrum block. So what changes once we go past the waterfall block? Open the Waterfall tab. In the main configuration of the waterfall block, you will find a time compression setting. If we set time compression to 100, the IQ stream feeding the waterfall, and therefore the file writer waterfall, is reduced by a factor of 100 in time. This saves a lot of hard drive space, but it also reduces temporal detail in the recorded spectrum. That is the trade-off. If you slide time compression all the way down to 1, the data going into the file writer waterfall is essentially equivalent to uncompressed IQ in terms of temporal resolution. To show the effect, we will use a time compression value of 100. Now we will compare data collection and file sizes. The file writer waterfall block is set to auto start. The raw IQ file writer and the file writer IQ Spectrum are currently deactivated. So, at first, the only active writer is the file writer waterfall. Click the main Start button. You can see that the file writer waterfall begins recording, and its status shows that data is being streamed. In the target directory, you will see the new recording file appear. We set the maximum file size to 1 GB on this block. That is the point at which a new indexed file would normally start. For this short demonstration, we did not add an index. Stop the recording. Check the file in the directory. Its size is about 52 megabytes. Now, we will repeat the test with all 3 writers active. Enable Auto Start on the Raw IQ file writer. Enable Auto Start on the File Writer IQ Spectrum as well. Now, IQ data will be recorded in parallel by the Raw IQ file writer, the File Writer IQ Spectrum, and the File Writer Waterfall. For this example, we will not stream audio to a waveform file, since that was covered in an earlier video. Click Start again. Watch the data rates in the status panel. The File Writer Waterfall is now writing at roughly 1.6 megabytes per second, thanks to the 100:1 time compression. The File Writer IQ Spectrum is writing at about 208 megabytes per second. The Raw IQ file writer is also writing at around 208 megabytes per second. Stop the recording and review the directory contents. You can see that the Raw IQ files have accumulated a large amount of data in a very short time. The file_streaming_waterfall recordings, which are filtered through the IQ power spectrum and then time compressed, are by far the smallest. This clearly demonstrates the benefit of time compression. You dramatically reduce file size at the cost of losing some temporal detail in the recording. This was a brief introduction to connecting a file writer block after the waterfall block and using time compression to stream data to the hard drive efficiently. For more information, check out our other videos on our YouTube page or visit AaroniaUSA.com. And if you have ideas for other videos you'd like to see, leave us a comment below.